Meet the Pixelbot 3000. Name anything and this Lego machine will be able to create a beautiful work of art of just that. After a couple of months, I should have this machine completely up and running to simply type in your subject and hit start. Well, hopefully. So the plan is to make an AI image generator, and I was thinking it might be a good idea to use these 16 by 16 base plates and then make a pixel art out of those like little 1 by 1 plates. Place them like 16 by 16. So wish me luck. So one way to make sure that it will always leave the pixel is by using like one of those round bricks. When I place it down and have something else coming through the middle to push it down, which is not very practical it seems like, but it does leave the pixel like every single time. Okay, I've got something else now, just some regular bricks that stack onto each other. If I were to somehow pick up this pixel, I can place it on here, pull, and it leaves the pixel. Dude, that works so well. Okay, yeah, I am definitely keeping this mechanism. So if I have that base plate and just connect a gear rack like this to it, I can probably have quite a satisfying mechanism to move the board forwards and backwards. That's looking quite alright. Oh, I missed this piece. That's better. Okay, it's a few days later now and I've done some building, some programming, some reconsidering, and I've hit my head, so please ignore that. But while programming, a 16 by 16 grid looks horrible. When I changed it to 32 by 32 pixels, it actually looked really good. So let me just rebuild this base to be 32 by 32 studs. Cue the montage. .32 by 32 base plate. We got it. It's really strong, this is not going to come apart, and the base plates themselves are really easy to remove because of this tiny lip. So I'm going to continue with the mechanism to actually move this platform. For this mechanism, I was thinking about making a large rack and pinion setup with one motor on each side of the board. By gearing the motors down a lot, this gear can spin very precisely and position the board in exactly the right spot. Although this was working very well, I still didn't feel too good about this mechanism. Sorry. So, it's a few days later now, and remember the rack and pinion mechanism we had going on? Well, just forget about that one, we are going to do it completely differently.
The wonderful world with no planning ahead and just improvising.
10 out of 10, would recommend. But the main reason I'm changing it is because I ordered Lego, since I don't really have hundreds of Lego 1x1 plates laying around. Along with these plates, I also ordered this new screw piece, and we're using this instead. You know what? Let me build the new mechanism to explain why. That was 6 hours of building. So this new mechanism has two major advantages. Firstly, the footprint is way smaller because it doesn't need the 8 extra studs on both the front and back, and it also doesn't need one of these motors on both sides of the bed. Which brings me to the second and biggest advantage, which is that it only uses one of these motors. Let me explain using this drawing robot I made. This machine used 2 motors to move the pen in one direction. Unfortunately, the programming of these motors doesn't really work that well. So when you try to move them simultaneously, more often than not, they move out of sync. And with a machine that needs to place Lego with less than millimeter precision, that's not ideal. With this mechanism, I can easily use one motor to move the bed by simply connecting it with some gears. This ensures that it will always move in a perfectly straight line. To see this in action, I'll connect the motor and start turning it. And as you can see, this mechanism just turns the screw, making the platform move. With that done, I think it's time we start looking at the pixel placement. So for this part, I actually did my homework by first looking online for potential designs. I saw this design from JK Brickworks and immediately wanted to try it out for myself. So I simply built what he made to try it out. Unfortunately, after building 15 columns, I came to the conclusion that it didn't work. And there is a good reason for that. In the video you can see that he uses clear pieces, while I'm using regular plates. These probably are slightly bigger, which causes a lot of friction. Luckily, I think I have an easy solution. So what I'm thinking is, if I replace the walls with these Technic lift arms, it should work, since these lift arms are slightly smaller than these Lego bricks. Although I don't think I can actually replace the walls, so let's rebuild this entire mechanism too.
The wonderful world with no planning ahead and just improvising.
Wait, why is it still going? I mean, any minute, right? Oh, okay, there it is. So I made a new one and it looks exactly the same. Oh, wait. Now it looks exactly the same. So there is actually a few changes. I made the walls a bit thinner, so now the pixels don't get stuck anymore because of the friction with the walls. And yeah, actually that's just about it. I also added this guard, and this makes sure that only one pixel can come out at a time. So now let's combine the two somewhere around here. Damn it! I made it one too wide. Not planning ahead and just improvising. After connecting the two parts, I started working on the X and Z axis. I wanted this to be a very compact system that was capable of positioning the pixel with less than millimeter precision. I went with this symmetrical design because I thought it looked good and it also helps with balancing the device. The left media motor controls the X axis, which is a rack and pinion setup this time, and the right media motor controls the up and down movement, which also is a rack and pinion mechanism. I also added a touch sensor to the X and Y axis so that the machine would be able to automatically reset its axis. All that needed to be done now was attaching the computer and connecting the wires. And with some finishing touches, the machine is now done.
1, 2, 3, 4.
So I've done some programming already, and my goal was to make this thing to be able to create a pixel art of anything, and this requires AI. I have basically created software that takes in any subject and creates a digital Lego pixel art of it. It starts off by using OpenAI's DALL-E 3 to generate a cartoony picture of the subject. After this point, my code takes over. You get a preview of the generated image so that you can either confirm the image, generate a new image, or crop the image. Unfortunately, our pixel art is obviously not going to look as good as the original image, since it is only 32 by 32 pixels and this image is 1024 by 1024. We could simply scale the image down to create a 32 by 32 image, but this actually looks horrible. The reason it looks so bad is that scaling down just takes the average color of nearby pixels to create a new pixel. This gives us these ugly washed out images, while we actually want the crisp colors like you normally see in pixel art. Therefore, I made the code divide the image into a 32 by 32 grid and pick the color of the center pixel of each space. If we run the code now, we get something like this. Now this already looks more like the final product we're going to make. It had way too many pixels, over 1 million, so we made it less pixels, about 1,000. But there is still too much in this picture for our machine to handle. Why? Well, it can still use over 60 million colors. I don't know about you, but last time I checked, LEGO didn't produce LEGO bricks in over 16 million different colors. This means we have to reduce the colors it can use to very specific colors. In the machine there are 15 colors it can place, including the white background. We can find what colors these are online. We make the machine go over every pixel, choose the color that is closest to it and replace it with the new color. Now we get something that our machine can actually create. And just for fun, I made it look like actual LEGO too. Isn't that just the best thing ever? I mean, come on, it looks so good. If you're happy with your result, which at this point you have to be, I mean, look at the image. You can confirm the image and the machine will now start. This is about as far as I got during the building process, because now we need an actual machine. This one. I have the machine now, so... Since this machine has to place pixels with such high precision, I added in these touch sensors so that it would be able to automatically reset its position. I got inspired by how my 3D printer's auto home function works. It basically moves towards the sensor at high speed, and once it reached it, it moves slowly towards the sensor so that it can determine the position more accurately. The Z-axis actually moves up without the sensor since it will naturally stall. It picks this point as the 0 point and then moves down a bit. Now that everything's set to 0, we can start making this work of art. For this, we need the machine to move to the correct color and then to the correct position. And do this for every single pixel in the image. I'm actually from the future and I already coded it, and I noticed that it was very annoying to keep up with all the pixels, the 1 by 1 pixels running out. So, to fix this, I want to code a nice quality of life feature that makes it automatically stop when it runs out of any color. This way, I don't have to stay near the machine to check the supply all the time. Again, I'm from the future and I've already coded this. So let's just get to the showcase, shall we? Now I need something this machine can make a pixel out of, but I don't have much inspiration. If only I had the world's most advanced, as far as I'm aware of, AI LEGO robotic head that could tell me exactly what I should make. Oh wait, I do. Yep, Dave is back. I took him apart for a while, but now he is rebuilt again. You've been asking for it, so there you have it. Hey Dave. With us is an AI LEGO pixel art machine. What should I make with it?
How about a giant Lego ice cream cone? Or a quirky robot holding a sunflower?
You have to pick one of those.
Oh, the tough decisions in life. Let's go with the quirky robot holding a sunflower.
Okay, let's try it out. That's an interesting one.
Let's get building. Time to show off my quirky robot holding a sunflower skills.
Let's go. It is finally time to test out what this machine can do. So let's just get right to it and start this machine. So let's just say a quirky robot holding a sunflower. Oh wow, that does look like a quirky robot holding a sunflower. I just think there's just a little too much detail in this image, so I'm going to regenerate it. Look at that! But Dave asked for a robot and not a human. Although it's debatable whether this is a human. Would you look at that? Well, that's a quirky robot holding a sunflower if I've ever seen one. I've never seen one, but... And there it is. Oh my god. Oh, I mean, I've been looking at it for a couple of hours now, obviously, but now that it's complete, oh, it just looks so good. Yes, man. This took, I didn't even know, like 6 months to make. Was it worth it? Yeah. I am so pleased with how this thing turned out. And just as an extra bonus, I also made this fox that you saw earlier in the video. It's a little clip of the machine making it. I'll just put it right there. But now there's only one question left. Does Dave like it? You know, let me just get Dave. There he is. As of now, Dave is not capable of judging his own idea. So in my next video, I will be giving Dave his much needed upgrade. So make sure to subscribe to see what Dave thinks of this work of art. I hope he likes it. And with that, thank you so much for watching.